So once again, good morning to all. Uh, Last lecture, what we have seen is the Coriolis component, and we have solved one problem related to that Coriolis component also. Also, we have discussed what are the points which are important from the MCQ point of view of that Coriolis component, right? So next point, what we are going to see is the cleans construction. As all the methods of calculating velocity and acceleration we have seen are the graphical methods. And this cleans construction is also one of the graphical method which we can use for drawing velocity as well as acceleration diagram with configuration diagram itself. What it means that the clean was one of French engineer who has dealing with these mechanisms, and in 17th century 16 at the end of 16th or starting of the 17th century. So in that case, what he find that if you want to calculate the velocity and acceleration of sliding crank mechanism, okay, that mechanism is nowadays also very popular mechanism, because that is the mechanism which is used for converting this chemical energy into mechanical energy. Later on, let it be, it will be converted into electrical energy or some of the other forms of energy. But this slider crank mechanism, that we are going to call it as a reciprocating type mechanism, that is the popular mechanism, and is the what we can say uh, most trustable mechanism, and efficient also we can say, though we are getting efficiency near about 35, 25 to 35, in between that we are getting efficiency of this reciprocating type mechanism for conversion of energy, that is chemical energy into mechanical energy. That what about I am talking is the all the mechanisms which are used for the reciprocating type engines. And you know that this reciprocating type engine is used almost right from your two-wheeler moped also we can say, to run big ships. Nowadays some people are talking about that it will get vanish, because we are getting that change in conversion of energy, and nowadays we are getting that automobiles which are having electrical motors, and that cars are running on the motors, so we are going to call it as electrical car. And lot many modifications are taking place in automobile sector because of that. And most of us get afraid because almost all the part of engine and that conversion of power from chemical to mechanical, that will be vanished from that automobile or car we can say. Basically nowadays we are getting cars of such types, but you know what, this conversion is required because these limitations of the electrical motors and storage limitation of electrical power. That's why we can't say it totally will get replaced. This automobile sector is one of the application of this internal combustion engine. It is not a total one. Okay, there are too many applications which are beyond that automobile. So we can concentrate on that, and um, nowadays also we are having much more scope in this internal combustion engine also. So like big ships or some of the aeroplanes or machineries, large machineries where excavation or mining machineries are required. Even in transportation also, large amount of transportation may be taken place with the electrical railways. But in most of the remote places, we require to have this machineries which we will be using this internal combustion engine. So uh, it was popular and it will remain. So for this reciprocating type mechanism, Clean find out that one easy way by means of which we can calculate velocity and acceleration of all points in that mechanism. So what he did, you can see here in this figure. Can you see this figure? Hello, am I audible?
Yes, sir.
Yes, sir.
Okay, so here just I will explain and later on we'll draw it. So basically this OCP is a reciprocating mechanism. Okay, so when we are going to see this OC is a crank and this CP is connecting rod. Okay, whereas this P, if it we are going to take with respect to stationary uh, points, then it will be piston. Okay, and in this case, this is what the angular displacement theta of this crank, and at this configuration, we supposed to calculate the velocity of various points in this mechanism. Also, we supposed to calculate the acceleration of various points in this configuration. Okay, so what Clean's done that he draw first that velocity diagram and acceleration diagram too of this mechanism, and later on he superimpose all these things, this velocity as well as acceleration diagram, by making some little constructions in the same this space diagram. So what he did, step by step we'll see. First of all, what he did that he extended this PC line, okay, up to the line which we can draw through O and perpendicular to the line of reciprocation. Okay, and where this PC extended PC line gets meet with the perpendicular line which we are going to draw, he mentioned there as a point M. And later on, he compared this OMC triangle with the triangle which we can draw here, that is small o, small c, and small p as a velocity diagram. And what he find that if we are going to rotate this angle by 90 degree, we are getting same configuration or similar triangle as we can draw with this space diagram only. Okay, and so he compare it, and later on he find that we can get this velocity of every point, that is point C and P, with without drawing this velocity diagram separately. Only we can extend this PC line and we can draw perpendicular line to the line of reciprocation through O, and we can get this velocity diagram and some mathematical calculations we have to do. So this is about the velocity. Later on what he did that he take C as a center and CM as a radius, and he draw one circle. Okay, and CP, he took the midpoint of the CP and he take it as a center and draw another circle. And where these circles are meeting with each other, he took that point and just joined that point with the line of reciprocation. And later on, the polygon which we get, that polygon is like NOCQ. This NOCQ polygon, he compare with the acceleration diagram, which we can draw with the formal method, the method which already we have seen, and just he compare with that and he find the similarity in that. And likewise, he find the acceleration also. So what we discussed right now, we'll see step by step. First of all, we'll concentrate on velocity diagram, and later on we'll concentrate on the acceleration diagram and its construction. Okay, so here what I'll take first reciprocating mechanism. Okay, we'll draw that reciprocating mechanism. So I'll take this as a line of reciprocation of piston. Then we'll take this as a crank. And this one as a piston. Okay, and we're having connecting rod. This is the ground on which piston is reciprocating, which is fixed. And here we are going to make one stationary support for the crank, that is main bearing support. Okay, this is also fixed. Okay, do you get it? So we'll name these points, and this point is O point. This is C point, and where the piston is connected to connecting is the P point. For this configuration, if suppose this angle is theta, can you draw a velocity diagram for this as by conventional method? And if yes, you just tell me what is the procedure by means of which we can draw velocity diagram. And if it is rotating with the angular velocity of omega, in clockwise direction. So can anybody of you me help how we can draw a velocity diagram for this? Huh? First of all, what we have to do, and later on how we can draw the velocity diagram. Roll number 39, Sujit Mani. Will you unmute yourself? Roll number 39. Can you hear
Yes,
me?
sir.
How can draw velocity diagram for this configuration? What we have to do first?
Velocity. First, we have to draw. We have to calculate velocity of
Huh?
OC.
Velocity of C with respect to O, right?
Ah,
And that is calculated by means of V is equal to
OC into omega.
OC into omega, right? OC multiply with the omega. Exactly. So once you got the dimensions of OC, and if you know the value of omega, you can calculate velocity of C with respect to O. That is nothing but linear velocity of C with respect to O, right? Once you get this value, we have to take scale, right? Second step is taking scale. And after taking scale, what we have to do? Anybody else? I'll ask to Viraj Patil, roll number 51. Roll number 51, Viraj Patil. Will you unmute yourself? Viraj Patil. What next step we have to do? Sachin Sutar. Will you unmute Sachin Sutar? Can you hear me, Sachin? Hello? Ajit Gaikwad.
Yes, sir.
What will be the next step? If we get the value of velocity of C with respect to O, what will be the next step?
Take stationary point
घेतला. त्याला
and
नाव देऊया काय?
O.
Small o. Then with scale, you have to draw one vector which will be perpendicular to OC. Am I
Yeah.
right?
Yes, yes.
Okay, that was expected from you. Okay, and this vector will be equal to whatever may be the value which we are going to get with multiplication of OC with omega and by taking the scale. So here we can say that we get the point C, and this will be the velocity of C with respect to O. Next step, we will take next step.
We know the position of P.
Hmm.
It is sliding, then we know that velocity of sliding body is parallel to it.
Parallel to the line of reciprocation. So we can draw one line parallel to the line of reciprocation through what? Huh?
Through O.
Through O, stationary point. Okay. Then if point is on OC line or OC link, then we can draw line perpendicular to OC through point C, and where this line of which we have drawn parallel to the line of reciprocation and the line which we are going to draw perpendicular to OC gets intersects with each other. That will be the point what?
Point P.
P, right? So vector CP indicates velocity of CP with respect to C. And vector OP will indicate velocity of point P with respect to O. Am I right? Did you get the velocity diagram for? Okay, thank you. Welcome. Hmm. Velocity diagram for the given configuration we have got, right? Now, what we'll do, we'll rotate this diagram by 90 degree. If you are going to draw or rotate this diagram by 90 degree, what will happen? This blue part will be exactly perpendicular, right? So I will make all these things as a dotted lines. Okay. Any doubt? Just I have rotated it by 90 degree. Okay, let now. Let be the directions of these velocity vectors we are supposed to have are rotated anti-clockwise by 90 degree. That we have to keep in mind. Okay, so directions which we are getting are just rotated by the 90 degree towards anti-clockwise direction. That we should keep in mind. Now what we'll do, that as suggested by the Cleans, we will extend this C or line passing through C from P. Okay, and we will draw one line which will be perpendicular to line of reciprocation through point O. Okay, I will delete this line because already we are knowing it. Now in this case, if we are going to compare, so I will give a nomenclature to this rotated triangle also. We'll call it as a, here as we have rotated this point and here we are getting point P. I'll call it as a P1. Okay, this point C is rotated and is moved to the C1 position. Okay, O is going to remain at its own place because just we are rotating it about O. Okay, so this whole diagram we have rotated by considering the center O. Now come to the configuration diagram. Then whether we are getting the similar triangle. I'm not saying exact same. It is a similar. Why? Because it is similar. Because the all angles which we are getting for this triangle OCP or OP1C1, that angles we are going to get for capital O, C, and we'll give name to this point which we have got as a M. Okay. Now by comparing this triangle OMC and OP1C1, these are the similar triangles. But what OP1 is indicating is the velocity of P with respect to O. What CP is indicating is the velocity of P with respect to C. And what OC is indicating is the velocity of C with respect to O. Am I right? Are you getting me or not? I'll make it exact same. At least did you get how to draw it? Yes. Did you get it?
Yes, sir.
Okay. So this O P1 C1. The similar triangles OP1 C1 and OCM. What we can write? We can write that distance OP1 divided by distance OM. This ratio will be equal to ratio if you are going to take MC divided by P1 C. Correct me if somewhere I am getting wrong. Is equal to again ratio OC1 divided by distance OC. Am I right? And this is equal to some constant. What that constant is, that we will find out. Am I right? Can we make this statement? हॅलो, हे असं म्हणू शकतो का आपण? सिमिलर ट्रायंगल आहेत. ज्यावेळेला मी हा वेक्टर घेतो त्यावेळेला त्याचा पण हा वेक्टर घ्यायचा, म्हणजे हा डिवाइड बाय हा घेतला इज इक्वल टू हा वेक्टर डिवाइड बाय हा वेक्टर सिमिलर ट्रायंगल मधला डिवाइड इज इक्वल टू OC1 वेक्टर डिवाइड बाय OC डिस्टन्स. हे बरोबर आहे का? हे वरती घेतो मी, कारण त्याच सिक्वेन्स मध्ये आपण small c should be there. इथपर्यंत बरोबर आहे? हे बरोबर आहे का? आता मला सांगा की व्हॉट ऍक्च्युली यू आर सेइंग दॅट OP1 इज इक्वल टू काय? OP हे डिस्टन्स आहे ना, दॅट इज वेक्टर, and is equal to what is it? Velocity of P with respect to O. हे बरोबर आहे? हे स्टेटमेंट बरोबर आहे का माझं? तसंच OC1 इज इक्वल टू आपण फक्त रोटेट केलेलं आहे काय? OC, आणि ती काय आहे? वेलोसिटी ऑफ C with respect to O आहे. हे बरोबर आहे? आणि तसंच आपण घेतलं तर C1 P1 बरोबर काय ऍक्च्युली? CP हा वेक्टर आहे आणि तो काय इंडिकेट करतो? वेलोसिटी ऑफ P with respect to C. हे तीन स्टेटमेंट बरोबर आहेत का? कुणीतरी एकानं उत्तर द्या. बरोबर आहे. हे जर बरोबर असतील स्टेटमेंट तर त्यातलं पहिलं स्टेटमेंट फक्त मी घेतो. ओके, हे and what I will write is equal to velocity of C with respect to O. आता velocity of C with respect to how we have calculated? Velocity of C with respect to O is equal to OC हे distance multiplied by काय घेतो आपण? Velocity, linear velocity is equal to angular velocity multiplied by distance. बरोबर आहे ना? हॅलो,
Yes, sir.
ओके. आता इथं मी ती व्हॅल्यू टाकतो आणि आहे हे स्टेटमेंट परत एकदा लिहितो. OC1 इज इक्वल टू OC हा वेक्टर इज इक्वल टू काय आहे ते? OC मल्टिप्लाइड बाय ओमेगा आहे ते. बरोबर आहे? ठीक आहे. आता मी काय करतो की OC1 हा 1 सफिक्स पाहिजे, या सगळ्यात मध्ये ते सफिक्सच पाहिजे कारण आपण त्यांना पॉइंटला नाव दिले. हे इक्वेशन फक्त रीराईट करतो. हाऊ आय एम गोइंग टू रीराईट इट ॲज OC1 divided by OC is equal to काय राहील? ओमेगा राहील, बरोबर आहे. काय केलं ह्या इक्वेशन मध्ये? फक्त हे ओसी आहेत या साईडला, ती मी या साईडला नेलं इथं. वेअर द ओसी इज डिनॉमिनेटर, बरोबर आहे का? हे ह्या इक्वेशनला आपण नाव देऊ इक्वेशन नंबर 1. आणि ह्या इक्वेशनला नाव देऊ इक्वेशन नंबर 2. What we can get from the equation 1 and 2? Can we write that कॉन्स्टंटच्या जागी can I write ओमेगा? हे बरोबर आहे का इक्वेशन? हॅलो, हे बरोबर आहे का? हे जे इक्वेशन सिमिलर ट्रायंगल वरनं मांडलंय त्याच्यातलंच OC1 हे घेतलंय फक्त आपण. स्मॉल OC1 डिवाइड बाय OC हे इथं आलंय. OC1 डिवाइड बाय OC इज इक्वल टू ओमेगा आहे. आणि हे तर आपण म्हटलंय की OP1 डिवाइड बाय OM P1C डिवाइड बाय CM OC1 डिवाइड बाय OC इज इक्वल टू कॉन्स्टंट आहे. त्या कॉन्स्टंटची व्हॅल्यू आहे ओमेगा. इथेपर्यंत बरोबर आहे?
Yes, sir.
Right. So I'll take this to the next slide. And आता आपण कन्स्ट्रक्शन केलं, वेलोसिटी डायग्राम ड्रॉच केली नाही आपण. ओके, आणि फक्त क्लीन्स कन्स्ट्रक्शन केलं सो दॅट वी कॅन गेट व्हॅल्यू ऑफ OM, CM अँड OC, कॅपिटल OC. ह्या व्हॅल्यू फक्त मिळाल्या आपल्याला. ओके, सो कॅन आय राईट हिअर that velocity of C with respect to O is equal to velocity of C with respect to O काढायचे आपल्याला. सो क्लीन्स कन्स्ट्रक्शन मधलं OC हे डिस्टन्स मल्टिप्लाय बाय ओमेगा. कारण OC1 हे काय इंडिकेट करते? फक्त OC मी पलीकडे नेले इकडं. OC1 is nothing but the velocity of C with respect to OI, which is rotated by 90 degree. Don't forget it. We are not getting its direction, we are getting only value. तसंच if I want to calculate the velocity of C with respect to, or P with respect to C. P with respect to C. What I should write? Cleans construction मधलं CM हे distance multiplied by omega. बरोबर आहे का? CM पलीकडे नेलं, P1C1, P1C is nothing but the velocity. Sorry. P1C कुठे आहे हे? P1C हे डिस्टन्स किंवा C1P हे डिस्टन्स इज व्हेक्टर CP, म्हणजेच वेलोसिटी ऑफ P विथ रिस्पेक्ट टू C आहे. इथं तेच म्हटलंय, वेलोसिटी ऑफ P विथ रिस्पेक्ट टू C. आणि तिसरं, इफ वी से वेलोसिटी ऑफ पॉइंट P विथ रिस्पेक्ट टू O, वेलोसिटी ऑफ पॉइंट P विथ रिस्पेक्ट टू O, काय करायला पाहिजे आपल्याला? OM हे डिस्टन्स क्लेन्स कंस्ट्रक्शन मधलं मल्टिप्लाय विथ द ओमेगा. So without drawing velocity diagram, if we do only Clean's construction, if we do only this construction, if we are not drawing this diagram, then also if we measure OM distance, if we measure CM distance, if we measure OC distance, and if you multiply it omega, we can get respective velocities of the respective points. That is how is the Clean's construction for velocity diagram. Do you get it? Any doubt? Hello? If you have any doubt, you are free to ask. परत एकदा विचारतो, कोणाला काही डाऊट आहे? समजलंय?
Yes, sir.
Very good. Okay, good.